What is up, 7th grade? This is lesson 89. We're going to be talking about diagonals, interior angles, and exterior angles. So the first thing we're going to talk about is a diagonal, and that's simply a line that connects two vertices inside a polygon that are not next to each other. So if I were to draw a line from this vertice to this one, that would be a diagonal, because this vertice and this one are not next to each other. But it would not be a diagonal if I connected this to this, that we call that just a side. So any two sides that are not next to each other, so this one, maybe this one, that one, that one, that one, right? All of those would be different diagonals, okay? So this is similar to number 1, but it says how many diagonals can be drawn from one vertex of the polygon that should be diagonals. So let's just pick one, doesn't really matter which one. Let's pick this one. Let's see how many diagonals we can draw. We can't draw to this vertex, because that one's next to it. But I can draw one over here. So I can draw this diagonal. And then I can also draw to this one. And notice I could not draw to this one because, again, that's next to it. Okay, so the answer to this would be I can draw two diagonals. Now, before we go on to the next question here, we need to see how many triangles. Notice whenever I drew all these diagonals from a single vertex, I just pick any one of them. Notice if I would pick this one, I could have drawn 1, 2 as well. Whenever I draw these diagonals, notice it changes this big black polygon into 3 triangles. Here's one, here's one, and here's one. Okay, now we know that the sum of all 3 angles of a single triangle, like so this angle, plus this angle, plus this angle, is equal to 180. Okay, so I know this one plus this one plus this one all total to 180. Right, all 3 of these come together to give me 180. Likewise with this one, and this one, they all would come together, if I added all 3 of those up, to equal 180. And also if I added this one, and this one, those would also give me 180. Now, notice this big angle here, this black angle, would be the same as the sum of this yellow, this green, and this red. This angle would be the same as this one. This big black angle would be the same as this green and this red. This black angle would be the same as this green and this yellow. This one would be the same as that one. That means if I added up all 3 of these yellow ones, all 3 of these green ones, and all 3 of these red ones, if I added all 9 of those up together, it would be the same as adding up all 5 of the black angles that are here. So to answer this next question, what is the sum of all the interior angles? And I guess maybe I should have defined what an interior angle is. An interior angle is just an angle that opens up to the inside of a polygon. So this is an interior angle. The measure of this one right here is an interior angle. This is an interior angle. That's an interior angle. That's an interior angle. That's an interior angle. So if I were to add all of those up, all I'd really need to do is I need to say 3 times 180. Why 3 times 180? Because I have 1, 2, 3 triangles, and the sum of each of those triangles is 180. And that will give me 540 degrees. So that would be the sum of all the interior angles of that polygon. All right, so it says Maria inscribes a regular hexagon. Pause real quick. They gave us the word regular, which doesn't mean it poops all the time. It means that it has all the angles that are the same and all the side lengths that are the same. So again, all the interior angles are the same and all the side lengths are the same. So she has a regular hexagon inside in a circle. Find the measure of each of find the measure of each angle of the regular hexagon. So we're going to do the same process again here. Let's go ahead and just pick an angle. I'm going to go and just pick A. And I am going to draw all of its diagonals. I can't draw to F because that's next to it, but I can draw one to E. I can draw one to D. I can draw one to C. But I can't draw one to B because it's right next to it. Now, if we look at it, we have 1, 2, 3, 4 triangles. So the sum of all the interior angles together is going to be 4 times 180, or 720 degrees. So that's the sum of all of them together. But they didn't ask us to find the sum of all of them together. They said find the measure of each angle of the regular hexagon. Now, because we know it's regular, we know that the measure of angle A is the same as the measure of angle B, the same as C, the same as D, the same as E, the same as F. So all 6 of those are the same. So what I'm going to do is I'm going to take that 720 that we just found, I'm going to divide it by how many angles we have. Again, we can do this because we know it's regular. So I'm going to divide that by 6, and each one of those comes out to be 120 degrees. Now, let's go ahead and talk about exterior angles, which is the last thing we're talking about for today. If I were to take one of these sides and extend it out of this side of the polygon, I have this angle right here. And this angle right here is what we call the exterior angle. So if you extend a side out, this angle would be how much you'd have to kind of pivot there to go along this side. So this angle right here is what we call the exterior angle. The vertex of the angle is at the vertex of the polygon. You extend one side out, one side's along the polygon. Okay? Now, if you notice something, this is a straight line. And we just found that the measure of one of these in here is 120. Which means, if we wanted to find this exterior angle, we would just say 180, that's the measure of a straight angle, and then subtract the measure of that interior one, 120. 0 minus 0 is 0, 8 minus 2 is 6, 1 minus 1 is 0. So the measure of this one out here is 60 degrees. And notice, if we extended the next one, this would give us another exterior angle here. If we extend the next one, another exterior angle here. Extend the next one, give us another exterior angle here. So notice each vertex has one exterior angle. So notice there is 1, 2, 3, 4, 5, 6 exterior angles. So over here they asked us, what is the sum? Which means if I added them all up, what's the sum of all the exterior angles? Well, I know one of them is 60 degrees, and I know that there are 6 of them. So it's going to come out to be 360 degrees. Now the really cool thing about this is that actually for every single polygon, doesn't matter if it's regular or irregular, doesn't matter if it's a hexagon, a pentagon, an octagon, a dodecagon, if you add up all the exterior angles, they always sum to 360, which I think is super cool. So that brings us to this next one here. It says, what is the measure of each exterior angle of a regular hexagon? And actually we just did that. So instead of hexagon, we're going to do octagon. So an octagon has 8 sides. I'm going to try to draw one over here that's regular. It's not exact, but just use your imagination. Okay, so if we wanted to find the measure of the exterior angle, we're looking for, if I extend one of these sides, we're looking for this angle right here. Okay, now we know that there are 8 of these exterior angles, and we know that if we added them all up together, we get 360. Now again, since it said that it is a regular octagon, that means each of those exterior angles would be the same. So I'm going to take 360 and divide by 8. I'm just plugging that on my calculator, and this comes out to be 45 degrees. So each of those exterior angles is 45 degrees. Your homework is down here at the bottom. It starts on page 614. You're going to do the practice set, the 89s, the 88s, and 7 more of your choice. Good luck, guys.